To supply electricity to the LED package, use copper wires with a core diameter minimum of 0.5 mm. It's best to use wires marked in accordance with the American standard like AWG24. The wire may be either a solid conductor or a multi-filament conductor. Solid conductor wires are cheaper and more rigid, whereas multi-filament conductor wires are more expansive and more flexible. The simplest way to obtain such wires is to use the standard Ethernet cable of 5th category, which consists of 8 such wires in different colors. As the LED package consists of the LEDs combined in 6 channels, it is preferable to use the standard cable containing 12 wires with the unique color marking. It would greatly facilitate the assembling, as each channel of the LED needs 2 wires for the power supply. Each conductor of this cable has a size of 0.34 square millimeters, meaning it is a little larger than the AWG24. Application of the larger wire makes it possible to avoid completely any heat at all during operation. The connector for hooking up the power for each channel of the LEDs in the package consists of 2 parts, the body and the clip which is to be fixed to it. The clip in turn consists of 3 pieces. The plain end of the cable has to be fitted into the first piece, then clamped to the eyelets. The second piece has a cable with a striped end which is also to be clamped to the next eyelets. The third piece is in the form of a small tube in which the mating connector needs to be fitted. This piece is on the board with the LEDs. Do not connect the power wire to the third piece. Let's separate one clip from the block. You need to use a crimper to clamp the wire to the clip. Put the clip into the crimper as is illustrated following. The crimper jaws plane is level with the eyelets which are to clamp the cable core. Make sure that the rear part of the clip is level with the crimper jaws plane. Now we have our clip fixed in the crimper. To fix the wire in the clip, first of all, strip the cable off the external insulation. Notch the insulation very carefully, not too deeply, to avoid damaging the wires inside. Remove a length of the insulation of about 3 mm. This is in order to attach the wires to the clip. Insert the stripped end of the wire into the clip fixed in the crimper. The eyelets clamping the cable core should already be half closed so as not to let the insulated cable in with regards to its larger diameter. Squeeze the crimper to a complete clamping. After that, release the crimper and remove the crimped clip. This is how a correctly crimped clip should look. The eyelets crimp the cable insulation. The second eyelets crimp the cable core. In this case, the cable core must touch the tube portion of the clip. It is possible to fix the wire in the clip without using a special crimper, but in this case, you will need to check how correctly the cable is fixed in the clip. This is how it looks. As you can see, the insulation does not reach the middle portion of the clip, and the stripped core does not touch the tube portion of the clip. To fix the stripped core into the clip more conveniently, it should be intertwisted. Afterwards, with the help of the sharp-nosed pliers called beak pliers, carefully clamp both sets of eyelets around the insulation and around the stripped part of the wire. Begin clamping from the stripped part of the wire. Squeeze the eyelets in turn. The clip with the eyelets clamped only around the stripped part of the wire should look like that. Now clamp the eyelets in turn around the insulated part of the wire. Then finally, clamp the eyelets of the connector. Squeeze the eyelets clamping the stripped part of the wire with this tool. Look how flattened this portion of the clip is now. The connector body has a triangle on it indicating the first terminal. Fix the clip in the body. Pay attention, the clip should be fitted the following way with the locking tongue on it at the top. Insert the clip into the body until you can hear a slight click. Look where the tongue is in this case. Then fix the second clip, which we have prepared with the help of the pliers. If the clip does not fit into the body, squeeze on the eyelets clamping the insulated part of the wire. A correctly fixed tongue will keep the clip fastened. A correctly made connector should look like this. To take the clip out of the connector body, move up the locking tongue on the connector body, after which the clip can easily be removed. The connector to the assembly terminals needs to be fixed with the tongues up. In this case, the connector should be put until touching at the power terminals. The correctly fixed connector should look like this. LEDs are the most efficient light sources today. They generate significantly less heat in converting electrical power into photo energy than conventional light sources. But LED crystals are very small. The standard size of the LED crystal is only 1 square millimeter. So the thermal flux density at this area is really big and more than 10 times as much as the same area with iron. It is important to remember that the LED crystal is a semiconductor element for which overheating is as harmful as it is for a computer processor. This is why it needs to be kept cool. LEDs are to be fixed first to special metal boards, which then are to be mounted on cooler sinks. There are also semiconductors on these boards. Power is supplied to the LEDs by these semiconductors. The standard metal board for the LEDs consists of a metal base, the dielectric necessary to avoid the risk of short-circuiting, the layer with conductors, and the metal which touches the lower part of the LED and receives its thermal power. This multi-layer solution has one big trouble spot from the point of view of thermal conductivity. It is a dielectric layer. The problem is that all dielectrics have very bad thermal conductivity. As a result, the thermal conductivity of the structure is rather moderate. Standard metal boards' thermal conductivity is from 1 to 3 watt per Kelvin. Special ceramic dielectrics are costly and allow thermal conductivity of about 10 Wmk. This value is considered to be very good. The application of such metal boards would lead to a temperature increase of the LED crystal in regards to the temperature of the cooler sink by 30 to 40 degrees, and even more for compact LED packages such as ours. As a result, the LED's light efficiency and service lifetime would decrease. To solve this problem, it is possible to install cooling fans into the LED lights. However, fans produce some noise and are not always very reliable. In the case of fan damage, LEDs may overheat and fail to function fast. Our task is to construct an LED light which does not need to be cooled through the usage of unreliable fans. To this end, we will considerably reduce the temperature difference between the cooler sink and the LED crystal through the cutting-edge technology of American company SyncPad. The SyncPad metal board for LEDs differs considerably from the standard board, as the metal of the base is provided with nibs which are in direct contact with the lower part of the LED. In this case, the dielectric does not hinder the terminal. The result is an amazing thermal conductivity of 135 watts per meter per Kelvin. That means 100 times more conductivity than the standard. As a result, the LED crystal heating is reduced drastically, and the temperature difference between the LED crystals and the sink is up to 15 degrees. Here you can see an LED package using a ThinkPad board on a thermal imager screen. As you can see, the temperature difference of some LEDs is even less than 15 degrees. As a result, we can easily use the LEDs with relatively small sinks in the mode of passive cooling. That is, without using any fans. To cool the LED package, it is necessary to use a sink. As far as the package is constructed with the application of the unique technology ThinkPad, you may use for its passive cooling a relatively small sink without the usage of fans. If you are going to use a finned heatsink, it should have a minimum surface area of 1300 square centimeters. When applying a pin-fin heatsink, its surface area should be a minimum of 1000 square centimeters. For example, the following pin-fin heatsink with the surface area of 1050 square centimeters would suit well. Put the LED package in the middle of the sink. Mark the centers of the prospective holes with a felt tip pen with a sharp tip. Choose the location of the mount holes in such a way that the drilling bit in operation will not get caught on a fin or pins. Also be careful that the 4 holes correspond with the LED package. Now we have 4 points for drill holes. Before drilling, it is necessary to make special small pits on the surface of the sink with the help of a center punch. When drilling, put the drill bit directly on that pit and it will not slip off the surface of the sink. As the center punch, you may use an expansion anchor, but it is better to use a special center punch because it is much more convenient. Put the center punch exactly into the center of our marks and in turn, carefully and precisely punch all 4 points. All these operations could be done with the help of the expansion anchor and a hammer. Take a drill bit with a diameter of 2.5 millimeters. Insert it into a drill and drill the hole. The holes for the screws should be counter-drilled a little bit in the upper part with the drill bit of a larger diameter. This will make it easier to screw in a screw. For this purpose, the drill bit of the diameter, about 4 millimeters, will suit well. Make a small edge with a depth of maximum 1 millimeter. For thread cutting in the holes, use a thread tap. It may be both for manual and machine operation. We would need the thread tap for cutting the thread with the diameter 3 millimeters. Before thread cutting, it should be lubricated with liquid machine oil or any liquid washing agent. As far as we are using the center punch for the machine operation, fix it in the drill driver and cut the thread. For mounting the LED package, use the screws with metric screw thread M3, usually used for fixing computer accessories. The screw should have a minimum length of 5 millimeters. Check the quality of thread cutting using a screw. Whichever screws you use, pay attention to the lower part of the screw head, ensuring it is flat and not conic. It is best to use a washer under the head, as in the case with the screw which we have applied. All 4 mounting holes should be made the same way. Use a special sink for mounting the package on heat pipes. It weighs less and has a significantly larger surface area than the pin-fin sink, and thus is the best way to keep the LEDs cool. The height of this sink is much less than that of the pin-fin sink, allowing a very thin illuminator to be made. And then the sink on the heat pipes is already provided with ready-made by fixing LED package holes with the thread M3. We strongly recommend mounting the LED packages on the sink with the captions to the board on the face of the heat removing cooling fin. To improve the heat contact between the LED package and the sink, you must use a special heat sink compound. There is a great variety of such compounds, but from our point of view, one of the best compounds is MX2 produced by the company Arctic Cooling. It is supplied in nozzle applicators of different sizes. The biggest applicator for 65 grams of heatsink compound looks like this. Then spread evenly a very small amount of heat sink compound on the lower face of the LED package. For one package, use 0.6 to 0.8 grams of heat sink compound. It is prohibited to apply a larger amount of the heat sink compound. The thicker the layer of the heat sink compound, the worse for the heat transmission. Then it is necessary to spread the heat sink compound evenly, making a very thin layer using a small plastic palette knife or something even like a plastic bank card. Carefully use a wad of cotton wool to remove the extra amount of the heat sink compound formed at the edges of the LED package. Then mount the package on the sink as if fitting it while making circulatory movements with a little amplitude. Pressure of 5 to 10 kilos is good enough. Screw the screws into the mounting holes. The best idea is to use a drill driver with a screw force stopper. This force should be strong enough, but you should be careful not to overdraw. Sometimes the LED package has a slight curve. After mounting it, should be pulled tightly to the sink, being careful that there's no gap between the package and the sink surface. Please ensure any extra amount of the heatsink compound is removed. The evidence of enough amount of the heatsink compound and not excessive shall be coming out of very little amount of the heatsink compound in the holes designed for the optical system. For the LED's power supply, we use special devices called drivers. They differ from standard power generating units installed in a TV set or a vacuum cleaner, for example, in that standard power generating units are to control the voltage and the driver's current intensity. That means that a standard power generating unit is to supply a consumer the desired voltage, and the consumer would request the desired quantity of current from the power generating unit. The driver would supply the consumer the current of the certain intensity. The LEDs are to be connected in a serial circuit. In this case, each LED in a circuit will give a certain drop in voltage. For long LED circuits, the total drop in voltage may be very large. Each driver may provide the voltage in the LED circuit no more than the voltage of the power generating unit supplying the drivers. That is why the long LED circuits should be divided into several short circuits, each of them served by their own driver. That is why many drivers are applied in an LED illuminator. For the LED circuit power supply in the illuminator, it is best to use not an isolated driver, but driver assemblies rather. There are two independent drivers on this driver assembly. Consider which switches and connectors are fixed on the driver assembly. Big square top plastic connector is marked as X2. It serves for supplying the actuating signal from the special microcomputer controller which operates the illuminator operational modes. The connectors SW1 and SW2 are fitted higher and lower than it. These connectors are designed to point out to the driver which channel it is to be owned by. Each of these connectors comprises 6 contact pairs numbered from 1 to 6. We would point out the driver's ownership to a certain channel by fitting a small jumper strap. Each driver is provided with a switch which sets the current intensity by the driver. For the first and the second drivers, these switches are called 1XI and 2XI accordingly. Such an installation of the switch should set the current intensity of 1000 mA. If the jumper strap is to be removed, the driver supplies the current intensity of 700 mA. If we put the jumper strap to this position, the driver supplies a current intensity of 1200 mA. Each driver in the assembly is equipped with the switch XP which turns the driver on or off. When the switch is in this position, the driver is turned on. If we remove this switch, the driver will be turned off. To establish the driver's ownership to the certain actuating channel, the following small jumper straps are applied. Please note, only one jumper strap is to be fitted on each connector. Now we are going to fix the jumper strap into the connector SW2 for the second driver. This jumper strap shall point out the ownership to the first channel. And for the first driver, we would point out the ownership to the 6th actuating channel by fixing the jumper strap into the connection SW1. All connectors, both the driver's ones and the power generating units ones, are designed for solderless wire management. So they may be cleaned from the insulation for the short length, their copper cores may be twisted and connected, but wiring is to be much more convenient if the following clips are fitted at their ends. Pay attention, the length of a tubular portion of a clip should be about 8 mm. Let's strip off the insulation from the wires to the length of 8 mm. Let's twist the inner copper cores. Let's fit the clip on the stripped part of the wire until bumping. Crimping the clip with the special crimper. The crimped clip should look like this. Pay attention to 3 pits which are to fix the wire inside the clip. If you do not have the special tool, you may use beak pliers, having crimped the clip first. Then make the same pits as the crimper can make. For this purpose, we shall use this part of the pliers. Please be careful not to chip off the clip's part. Thus we have obtained the same result for both ways of dressing. To fit the clips to the driver's assembly, we should use the screwdriver with a tip width of about 2 mm. Removing a screw from the connector for some turnarounds. Thus the terminals inside the connectors have been raised. Let's insert the clip into the connector until bumping. Screw tightly, making a slight effort at the end. As a result, we have connected the orange cable to the positive clip of the connector and the red one to the negative clip. The driver assembly is provided with 3 screw connectors designed for wiring. Consider them from left to right. The connector X1 is designed for supplying the power to the driver's assembly from the power generating unit. For this purpose, it is recommended to apply a copper wire with the conductor area minimum 0.5 square millimeters. That means marking in accordance with the American standard like AWG22. 2 other connectors, 1XL and 2XL, are designed for supplying the power from the driver to the LED's circuit. Each connector's terminals are marked for the positive and negative leads. Our drivers are to be supplied with power with the direct current from 24 volts to 60 volts from the special power generating unit. In this case, each driver can provide the power supply from 6 to 17 up-to-date powerful LEDs. We recommend using the power generating units with high efficiency output as the driver's power generating units, as far as they do not need any fans for their operation. Not costly and reliable power generating units suitable for our purpose are manufactured by Taiwan company Meanwell. The best choice for us is the power generating unit of the series SDR. They are represented by the models with the capacity from 240 watts to 960 watts with the output voltage 48 volts. For a small amount of the LED's packages from 1 to 6 pieces, the power generating unit for 240 watts would perfectly do, and for 7 to 12 pieces, the power generating unit for 480 watts. For 13 to 24 pieces, the power generating unit for 960 watts. These power generating units can be easily mounted on the standard block DIN. These power generating units have only one slight disadvantage. As far as they have only one output voltage for the power supply of the microcomputer controlling lighting, it is necessary to use the separate power generating unit. You may also use the power generating unit developed by us. It also does not need any fans for its operation. It is good for supplying power to 1 to 9 packages and has the separate power supply output 12B. Unfortunately, this power generating unit does not have a case, so the decision concerning its installation should be taken by the owner themselves. The connectors of this power generating unit have the following marking. It is important to remember that any power generating unit is to generate a fair amount of heat, which is why it should not be covered in a limited value. It is desirable to provide a permanent supply of fresh air to the power generating unit. You should also be careful to secure the power generating unit away from water or its stem. As far as the LED controller requires for its power supply, the separate voltage from 5 to 12 volts, you must combine negative terminals of the power generating unit with the LED's power generating units. In case you are using our power generating unit, this task shall be solved very simply as follows. Never turn on the illuminator without the preliminary combination of the negative terminals of the power generating units, or your illuminator's parts will be damaged. Connect other wires to the power generating unit. Pay attention to the fact that the wires supplying the power to the power generating unit and further from it to the driver assembly are significantly thicker than the controller's power wire. Connect the controller to the power generating unit. First, the negative lead, then the positive one. Let us remind you that for the controller's power supply, the power generating unit with the voltage from 5 to 12 volts should be applied. The capacity of the power generating unit may be very little because the controller consumes the power maximum 100 milliwatt. To control the light intensity of the LEDs, the driver of the LEDs receives commands from the special microcomputer called controller. The commands from the controller to the driver are transmitted by the flat cable with 10 conductors. This standard flat cable with the conductor's step to 1 mm. To help the signals from the cable be transmitted to the driver, it is required to fix the following standard connector to this cable. Pay attention. On the connector there is a triangle pointing out the position of the first terminal. First, open the connector by lifting the upper clamp strap the way to form the gap for the cable between it and the connector's terminal studs. Then fix into the connector the flexible flat cable the way that the colored first conductor of the interface cable would correspond to the first connector's terminal marked with a triangle. Then press the wires of the interface cable into the connector with the help of a clamp strap. The simplest way to do it is to use the jaws. Fit the connector into the jaws and carefully and smoothly clamp the strap tight. Make sure that the plastic fixing locks located on the clamp strap are now closed, meaning that their lower part is level with the lower surface of the connector. To compare, look at the lock's position when the fixing strap is raised slightly. If you do not have the jaws, you may carry out this operation with the help of any flat, hard metal object. We do not recommend using the tools inappropriately, but in the last resort you may use a slide gauge as we have done it. Put the connector vertically on a rigid surface, locating on it a metal object. Make a fairly high effort and carefully without thrusting press the fixing strap the same way we have done it with the help of the jaws. The connector is ready, looking exactly the same way as it is in the case of the first dressing. Thus we have demonstrated all the operations for the illuminator preparation for assembly. Furthermore, this is how to assemble the illuminator on the base of 2 LED matrices. We have to prepare all required cables in accordance with the electrical diagram. It should look like this. Here are the illuminator's components: the power generating unit, the controller, the interface cable of the controller, which manages the driver's assemblies, the driver assemblies, the LED packages, the controller supplied with power by the power generating unit. The driver assemblies are also supplied with the power by the power generating unit. The LED packages are supplied with power by the driver assemblies. Each power channel of the LED package is to be highlighted with a proper color. For example, this is a power channel of red LEDs, and the next one is for violet LEDs. Prepare all power channels very carefully in strict adherence to the diagram. Prepare an interface stub. Set on each driver the correct intensity corresponding to the type of the diodes which are supplied by the driver. All these components are needed for the illuminator assembly. Listed from left to right: the interface cable with the fixed connectors, the power generating unit, the controller, the multiple socket, the bunch of the LED's power cables, 2 sinks with fixed LED packages, 3 driver assemblies, the sachet with jumpers which shall point out to the drivers the channels they belong to. Further procedure of assembling is so simple that it can easily be carried out even by an untrained person. Start by connecting power to the LED packages, checking carefully the electrical diagram. Please note, do not touch the primary optic of the LEDs with your hand. If this occurs, carefully clean the optic with a wad of soft cotton wool dampened with isopropyl alcohol. Now connect the power supply to the driver's assemblies, carefully observing the electrical diagram. Be careful to screw the connector in tight. Set the channel switches on the driver's assemblies into the proper position. The first channel, white LEDs. The second, violet LEDs. The third, dark blue ones. The fourth, light blue ones. The fifth, cyanogen. The sixth, red ones. Set up the required currency intensity. Then carefully check that the LED packages and driver's connection is correct. Fix the connectors of the interface cable into the driver's assemblies, checking that they are fixed tight. Then connect the controller to this cable. Finally, make sure that all the connections have been carried out in strict adherence to the electrical diagram. Plug the power generating unit into the circuit. The illuminator has started working. Please note, in this mode the illuminator should operate in accordance with the daily cycle which is preset in the controller. There is a possibility that it is night at the moment in your time zone in accordance with the controller's timer. If the LEDs have not turned on, please disconnect the power generating unit, wait a minimum of 10 seconds, disconnect the interface stud from the controller and turn on the illuminator again. The LEDs will start working with 100% capacity. Then also disconnect the power generating unit, wait 10 seconds and connect the interface cable to the controller. Important! The LED is a point source of very powerful light. Please avoid eye damage. Never look directly at the LEDs with unprotected eyes. If you need to do so in order to check the correctness of the LED package channel connection, you should use the minimum supply current of the LEDs or wear dense dark sunglasses. A LED illuminator is able to produce the light of any spectrum and almost any luminance. To control the illuminator light, use the controller, which is in turn controlled with the help of any device operating system Android version 2.3 or newer. To demonstrate what is needed to be done to set the control program, take an inexpensive tablet computer. Install on it the control program as to the standard USB drive with the help of a standard USB cable. After that, we can launch the Standard Program Explorer, which is installed on any device using operating system Android. Enter the directory internal memory. Then enter the subdirectory download. Find and launch the setup program of the controller's application LED controller. Allow the application setup. Wait until the end of the setup. The application has been set up. Find it in the list of the setup programs and touch the application icon for a long time, bringing it to the desktop. The control program is completely set up and is now on the desktop. Now provide the connection to the controller through the wireless communication Bluetooth. For this purpose, activate the standard control panel. Activate Bluetooth settings. Use the function Drive Search. In several seconds, the drive with the name HC05 should be found. This is the controller's name. Now enter its pin code 1234. The control program is completely ready for operation. All described operations should only be carried out once while setting up the program at the very beginning. Now launch the Illuminator control program. The first thing we can see is the real-time control mode. Take note, there is a controller communication indicator in the top right corner. For the first second, it is inactive. That means looking the following way. The program can control simultaneously several controllers. If you have several Bluetooth drives specified, you should choose precisely the illuminator, the controller of which you would like to communicate. For this purpose, press the arrow which is to the left from the button off and choose the drive named HC05 in the drop-down list. At the next start, the program will make the connection to this drive automatically. If you have only one controller specified, the program will make the connection to it automatically. In 5 to 10 seconds, the connection with the controller will be made and the indicator will be lightened with green light, and it looks like this. So the connection has been made and you may start operating the illuminator. Moving sliders along the control strips, we can change the light intensity of each channel separately. Thus we can make the light picture most pleasant to our sight. To operate the sliders position, we can move them along the strip as simply as pressing the finger on that part of the strip where we would like to move the slider. Further, you may pass in the mode of setting daily cycle. To do this, click on the tab Scheduler at top of the control program. Then fast data readout from the controller will happen and we can see in the top part of the screen the daily schedule, and below there are stripes of setting operational modes. For more detailed information concerning the program operation, you may refer to our site in the section devoted to this point. To complete the program operation, hit the escape key. Take into account the fact that if you escape the control program in the mode of real time, the daily cycle settings will be replaced by manual settings made by you. For the controller to operate in accordance with the daily cycle, you should escape the program via the tab Scheduler. Other operations concerning the illuminator's assembly would depend on its construction and would differ for each illuminator. That is why we would not light them up. We hope that you would receive only positive emotions from your LED illuminator operation.